All right, ladies and gentlemen, sorry I can't be there today. One of my boys is not feeling well, so we're going to go get one of those rapid tests and make sure he's doing okay. So I am at home teaching you guys with this video, chapter 11.3, which is solving quadratics using the square root method. Okay. Today, we're going to focus on goal number 2, again, the square root method. We already did the factoring, but I'm going to go back and we're going to do example 1 using the factor method and then show you the square root method and show that we can use either method. But, just so you guys see, you can see the relationship between them, that this is like another tool in your toolbox to solve a quadratic. Okay. So as I take a look, I've got 4x squared equals 36, and we're going to try the factor method. So I've got 4x squared equals 36. Usually when we're factoring, we get our stuff equal to 0. So I'm going to go ahead and subtract 36 over. And now we get 4x squared minus 36 equals 0. Okay. Well, anytime we factor, we always look for GCFs. So in this case, I notice the 4 and the 36 can be factored by 4. And now I've got x squared and then minus 9. Negative 36 divided by 4 is negative 9. And then I see a difference of squares here. I see x squared minus 9. So I'm going to go ahead and factor that to 2 binomials. And as I take a look, factors of x squared, we know are x and x. And then factors of negative 9 that add up to 0, we know is plus 3 minus 3. Try that again. Minus 3. Now, anything with an x we set equal to 0, and I've got x plus 3, x minus 3. So I should get plus or minus 3 as my solution. So there's 2 answers there. Okay. Now, that took quite a few steps here. I took 1, 2, 3, maybe 4 steps. Well, let's take a look at the square root method. If I've got 4x squared minus 36, or equal to 36 in this case, the first thing I would do is I'm trying to isolate this x squared. I'm trying to get this guy by itself. So I'm going to divide over the 4. And what we get is x squared equals 9. And now my last step, to undo something that's squared, all I have to do is square root both sides. And I simplify, and I get the square root of 9 is 3. Now, to make sure that we get both answers, the little trick here is anytime you square root both sides, you must include a plus or minus. And that will guarantee that you'll get those 2 answers that we're looking for. Okay, so again, square root both sides, make sure you get plus or minus. Okay, now everybody forgets that. So Mr. Gotch will always say in class, don't forget the plus or minus. So don't forget the plus or minus. Anytime you square root both sides, make sure you include the plus or minus in your final answer. Okay, so final answer plus or minus. So again, this is the square root method. As you take a look, it really only took about 2 steps. It takes less time, and it's a nice thing we can use. Okay, so as we take a look, let's look at example number 2. I've got x plus 2, or excuse me, x plus 3 quantity squared equals 81. And I have something that's squared here, so I'm ready to go. I'm ready to square root both sides. Well, when I do that, I get x plus 3, and then the square root of 81, we should know is 9. Okay. Now, Mr. Gotch always says, don't forget the plus or minus. So we're going to have a positive and a negative 9 now. Okay, so again, square root both sides. Don't forget the plus or minus. Now, what that means is we have 2 equations here. We've got x plus 3 equals positive 9. And we got x plus 3 equals negative 9. We go ahead and subtract the 3 over. Subtract the 3 over. And then we simplify. So we get 9 minus 3 is 6. And we get negative 9 minus 3 is negative 12. And those are our two answers. Okay, this is again solving quadratics using the square root method. Okay. All right. So let's take a look at number 3 here. It's hard to see, but it's not too bad. I've got x squared plus 49 equals 0. So first thing is we want to isolate this x squared. So we want to move this 49 over. Okay, so we're going to go ahead and subtract this guy over. And now we get x squared equals negative 49. And now we're ready to go. We square root both sides to get rid of that squared. And when we plug this in, if we were to plug this in the calculator, we get a no real solution. We get an error message. Okay, I can even show you that right here. So if I do the square root, negative 49, I get non-real answers. Okay, well, if it's not real, that means it's imaginary. And we talked about the other day in chapter 10:7. This is really the square root of negative 1 times the square root of 49. We know the square root of 49 is 7. And we talked about what the square root of negative 1 is. We should know that that's I. Okay, so we get x equals 7i. Now you plug that in MyMathLab, and you're wrong. And what did we do to both sides? Don't forget the plus or minus sign. So final answer, if you're typing this in to your homework tonight or tomorrow during Async Tuesday, SAT Tuesday, all right, make sure you have the plus or minus sign. So you can either do 7i, comma, negative 7i, or you should be able to do the plus or minus 7i as your answer. Okay. Not too bad. So again, if I look at number 4, it's already set up for me. It's already has the x squared isolated. I have x squared equals negative 25. All we do is square root both sides. Again, when I square root negative 25, that's the square root of negative 1 times the square root of 25. We know the square root of 25 is 5, and the square root of 1, negative 1, is I. Plug that in, and wrong. Don't forget the plus or minus. Okay, so really not too bad. Okay. When I take a look at number 5, I've got the quantity of t minus 3 squared equals negative 25. So this thing's ready to go. I have my squared quantity already by itself. So I square root both sides. So in this case, I've got t minus 3 now. When I square root something squared, it completely falls out. It just leaves me what's inside the quantity. And now with the square root of negative 25 we just did over here, we know that's plus or minus 5i. Well, we still need to solve for t here. So I'm going to go ahead and add the 3 over. Okay. And what we end up with is 3 and then plus or minus 5i. Okay. Now you can try plugging that into MyMathLab and see if they accept that. Maybe they will, maybe they won't. So you might need to separate it as 3 plus 5i, comma, 3 minus 5i. And that's that complex number that's in our directions. It says find all real and complex solutions. Remember, this is a complex number where there's a real part and an imaginary part. So we got two answers. We have 3 plus 5i and 3 minus 5i. Okay. Remember, have 3 first and then the I term second. So don't write this as 5i plus 3. Okay. For proper complex number, they want a plus bi. Okay. All right. Let's take a look at the next one. We got example 6. Example 6, I've got the quantity of 6y minus 5 equals negative 8. So to get rid of the squared term, we're going to square root both sides. All right, so in this case, I get 6y minus 5. And that equals, and let's break this thing down. I've got the square root of -1 times the square root of 8. Okay. Well, we know this. 8 breaks down to 4 and 2, 2 and 2. So I have a pair of 2s. I write that 2 on the outside, and then, oh, that guy, he's left on the inside. And then the square root of -1 we know is I. So I'm going to put the I right there. Okay, so I have 2I root 2. And then we square rooted both sides, so don't forget the plus or minus sign. All right, so next, we need to get this 6y minus 5 so that we have the y all by itself. So I'm going to go ahead and add the 5 over. I'm going to go ahead and put that in front so it looks like this. So I have 6y equals 5 plus or minus 2I root 2. Okay. Now the last thing I'm going to do is I'm going to divide everything by 6. And I'm going to do it individually because that's probably what my math lab is going to be looking for. Okay. So I take a look. I've got y equals 5, 6. That doesn't reduce. But in this case, I have numbers on the outside that I can reduce. I have 2 and 6. So I'm going to reduce those. 2 divided by 6 reduced by 2. So I'm going to put a 3 there. And I end up with plus or minus I root 2 all over 3. Okay. Now, you can also write it like this. 5, 6 plus or minus root 2 over 3i, like that. I'm okay with this. My math lab might want it written like this where, you know, they have this root 2 over 3 in front of the I. Okay. For me, this is totally fine. But sometimes, as you guys know, the word of the day for my math lab is finicky. Right? Sometimes that's finicky. So we got 5, 6 plus or minus root 2 over 3 and then I. Okay. All right. Got a example 7 now I want to share with you guys. And again, if you guys have questions on this, we always have Wednesday that we can come in, and it's a normal day. We'll take questions on that day. Okay. Nice thing with this one, number 7, it's all ready to go. I have x plus 7/3 quantity squared equals -16/9. When I square root both sides and I have a fraction, I'll usually square root the top and the bottom. So now what I have is I'll have x plus 7/3, and that equals the square root of 16 we know is 4. The square root of 9 is 3. And remember, it's a square root of a negative, so that's going to be I. Now, always forget this. Square root both sides. Don't forget the plus or minus sign. Okay, so you square both sides. Don't forget that. Last thing we have to do, look at how easy this is. We just have to move and get this x by itself by moving over this 7/3 using subtraction. All right, so I would probably put that -7/3 in front, and then plus or minus 4/3 I. Okay, so final answer, there's your complex number. -7/3 plus 4/3 I, and then -7/3 minus 4/3 I. You get 2 answers there. All right, ladies and gentlemen, I flipped the page, and now we're back up to example 8 and 9. As I take a look at number 8, try as you might to get the square term by itself and then square root both sides. The issue that we have when you're using the square root method is we have an x term here. We have that oi term, that middle term. Okay. When you're working with the square root method, that only works if you have a squared term and then what we call a constant or a term that has no x. If you have something that looks like this, 2x squared minus 5x equals 0, and it has an x term, then the square root method is something that we just can't use quite yet until we learn something in the next few days, which is called completing the square. Okay, so the only way to do this one, to answer this question, is to use that factor method. Okay, and you guys remember the first rule of factoring? GCF. As I take a look, I got 2x squared minus 5x. I just said x twice. So I'm going to take that x out. And now that leaves me with 2x minus 5. Set each one of these x's equal to 0. So we get x equals 0 for that one. And then we have 2x. We have 2x minus 5 equals 0. Some of you guys are really smart and can answer this. I'm going to show the work so you can see it. I'm going to add the 5 over. I get 2x equals 5, and then we're going to divide by 2. So final answer, we get 0 comma 5 halves, or 5 over 2. Okay, so not too bad. All right, number 9, let's finish up. We want to isolate this x. Okay, this one doesn't have that x term there like this one, so we can go ahead and use that square root method. But we want to isolate the squared term. So we need to get this 100 over there. So let's move this hundo using addition. We get x minus 5 quantity squared equals 100. And now do we remember how to get rid of that squared term? You betcha. Square root both sides. And the square root of 100 we know is 10. Mr. Gotch always says, don't forget the plus or minus sign. So make sure you add that plus or minus there. Okay, key step for today. A lot of kids forget it. Okay. And now you can write this as 2 different equations. Or for me, I like to do this. I like to do that. I'll add the 5. So we get x equals 5 plus or minus 10. Okay. Now, if you try to type that in my math lab, it's wrong. They always want it simplified. This is something that we can simplify. Okay. So if I write this, simplify it. 5 plus 10 is 15, and 5 minus 10 is negative 5. So again, 5 plus 10 is 15, and 5 minus 10 is negative 5. Final answer. That's what I'd be typing in my math lab. All right, ladies and gentlemen, as we take a look, I've given you 9 good examples. Okay, this is, again, an example where square root method ain't happening, right? Can happen because of that x term. And we're going to show you in the next few days how to complete the square and answer a question like that. Okay, so now you have 2 tools in your toolbox. All right, as we take a look, we should know how to solve quadratics by factoring from what we did on Friday. And now our new tool is the square root method. You guys have a great day. Good luck on the SAT for any juniors. And we will see you guys on Wednesday.